I'm John Wilker, the organizer of 360 IDEP. I hope you enjoy this session recording, but first I wanted to mention one thing. We've served the community since 2009, and over the past few years we've had to take on debt in an effort to keep the conference alive. After several unforeseen challenges, not the least of which is a pandemic of indefinite duration, we've had to make the hard choice to end the conference as we're now facing over $100,000 in debt. As a result of requests from the community of how they can help, we've created a GoFundMe campaign. If you're inclined and able, please consider donating to help keep 360 IDEF going. The QR code after this will link you to the campaign. Thank you. Enjoy the recording.
Good afternoon. That's better. I'm Bob Wakefield. Welcome to my talk. The title is Manage a Group Activity Session with a Deterministic Finite State Machine. This talk has three main parts. First, I'll go lightly over the Group Activities API. I'll skip over the specialized shared media experience. I'll mention things that gave me trouble. The documentation and sample code will be enough to get you started after that. Then I'll go back over some of those quirks and mention some things that work well enough for shared media experience, but not so well for generic group activities. Then I'll show you a straightforward way to turn flows from a state transition diagram into code to build a deterministic finite state machine. But first, some background. Group activities provide apps a low bandwidth data channel during a FaceTime call. Apple introduced the framework in WWDC 2021 for iOS 15 and macOS Monterey. The Group Activities API is the basis for Apple's SharePlay shared media experience. Apple seems to use the terms SharePlay and Group Activities interchangeably. I think it's important to distinguish between the two. The Group Activities API in general has potential for so much more than shared media experiences. For example, Jordy Bruin wrote Navi, an app which uses speech recognition on your end to add subtitles to the other end of a FaceTime call. This is brilliant. It's a wonderful application for the hearing impaired. He originally also offered translation services. Unfortunately, Jordy will have to withdraw his app when iOS 16 goes live. Apple has changed the audio subsystem for iOS 16. They made it impossible for other apps to get access to the FaceTime microphone audio stream. I hope that Apple makes this possible again soon, perhaps in a more managed fashion. I searched the App Store with the SharePlay keyword. There are Watch Together apps and Listen Together apps, but these are what came up in the third category. This is all that came up in the third category. I got one result when I searched on group activities. Here's my current side project. I started with the Romotive Romo. It now also supports the Pivo Pod. I made this video in July of last year. Oops. There we go. Let's see if I can make it play. Thank you. When you're testing one of these apps, you really want to mute the audio on both ends. The feedback howl is horrible. Thankfully, FaceTime lets us do that before we accept the call. All that fumbling around convinced me to build a state machine to manage the session, because there was just too much fiddling. To connect arbitrary devices over the internet requires an intermediary. For servers, that's the DNS system. Group activities can link any Apple devices which can connect to FaceTime call anywhere in the world. With iOS 16, they can connect through Messenger. Connection requires approval from each user. This is a good thing. We don't want FaceTime to answer automatically, though I hope people will file a radar asking for a very carefully selected green list. Now I'll go over the Group Activities API. First, set the entitlement. You only do it once per project. You set it in Xcode. It's easy to forget. So don't forget. You'll be writing test apps all the time and you'll forget. The group state observer reports the session eligibility state. Either you can start a session or you can't. Previously, that meant whether a FaceTime call is in progress or not. With iOS 16, we can start sessions through Messenger, though I haven't done that yet. Define an activity type conforming to the group activity protocol. This sets the topic for a session. It carries session-level information. It requires a static identifier string, activity identifier string, for a particular group activity. Something like your bundle identifier plus a suffix. According to the documentation, one app can support multiple sessions, though I haven't tried that either. Each session would be for a separate activity type. I have tried using the same activity type with two different apps. That did not work. It's probably safe to say that the activity identifier plus the bundle identifier plus the signing certificate must all match. The activity type must be codable. We can change fields on the activity on an existing session. The app can subscribe to published fields for updates. The group activity metadata determines the nature of the session, whether shared audio, shared video, or something else. The system displays the title, subtitle, and preview image from the metadata in its prompts. This helps the user on the other end of the call know what's going on. You can provide any preview image you like. The system will scale it down. For a shared media experience, you might want to use a poster or album cover image. The session type for sessions which aren't shared media experiences should be generic. You must call one of two functions to start the session. Prepare for activation uses the system-provided pop-up, passing the result of the user's choice to a closure. Activate adds a join share play option to the FaceTime screen. iOS 15.4 gave us two more ways to start a session. More on that later. The sessions function returns an async collection. It provides an active session when one becomes available. So you basically async await on the sessions function, return value. Group sessions are for a specific activity type. The app must await the session and explicitly join it. You cannot start more than one session of the same activity type. Starting the second session replaces the first. You can change the activity on an existing session. That's one way to make session-level information available to all devices in the session. Sessions become available from an async collection on the activity type, returned by the sessions function. The group session messenger is the application data channel. You pass the session to its initializer. iOS 16 introduces reliable and unreliable messaging, like TCP versus UDP. Timing of delivery is not guaranteed. Apps pass messages through Messenger. Messages can be any codable type. If you want to send and receive multiple types of message, you'll need to await each individual type or protocol. I haven't found it necessary to have multiple types of message. The message payload can be an enum with associated values. Apple almost certainly sends messages to coordinate playback in a co-viewing session. It's a low bandwidth data channel. No audio or video passes through it. iOS 15 limits messages to 64K. iOS 16 expands that limit to 256K. You can't send video. You can't send large images. I can imagine sending a large image in pieces as a mosaic, kind of like a Mars rover. Each device which joins the session is a participant. The app can subscribe to receive events when devices join and leave. It might be important to have a quorum of participants in the session. iOS 15 added new features. The group activity sharing controller is a way to start a FaceTime call and automatically activate an activity when the call connects. iOS adds share play options to share sheets. The app can configure this. The user can start a FaceTime call and group activity session with information from the current app state. Quirks and features. Declaring an activity type for a group activity does not get you a session. It must be activated explicitly. For some reason, it took me some time to figure that out. Maybe it won't for you. One device must activate the session. Figuring out when to do that is part of the fun. There are drawbacks to multiple devices activating the same activity. In my experience, checking for an existing session is unreliable. Some apps do seem to do it properly. Activation of a particular activity type during an existing session will disrupt your user experience. You may not always get every event. For instance, if a user ends the call in the middle of a session, the app will receive an end of session event, but no event for loss of eligibility. The new functions to start a session add new flows without eliminating the old ones. This is a state transition diagram. It's a naive, happy path to starting a session. This isn't the most naive path possible. The app doesn't have to wait for other participants. There is something to be said for running everything through the session, all the time, whether you're connected or not, just as a heavily deep linked app might do well to run all the operations through the deep link mechanism. It's naive because it unconditionally activates the group activity. If you call prepare for activation during a shared media experience, the system pops up a message asking the user what to do. Do they want to start a new program or stay with the existing one? If you call activate instead of prepare for activation, you can still get an alert. The system alerts are tailored to the shared media experience. They don't make much sense for generic group activities. This pop-up is from Apple's Draw Together sample. It starts a new session whenever someone wants to erase the current drawing. We can trigger this pop-up by activating an activity when a group activity session of the same type is already in progress. This is not a good user experience. The user does not expect to see it. There is no obvious choice. It's not like the shared media experience where it's obvious they're going to play a different selection. Depending on what the user chooses, their devices can end up in separate sessions. We need to avoid triggering this pop-up altogether. I said before, the group state observer does not signal loss of eligibility when a user ends a call, though the session is invalidated. It can signal loss of eligibility, but not if you've got a session in progress. Generally, there is more than one happy path to starting a session. And here's again with the new API and the group activity sharing controller and how it looks on the screen when you're using it. I decided to build a deterministic finite state machine to manage the group activity session. I'm going to show you how to build one with stone knives and bear skins. A deterministic finite state machine is defined as a finite state machine with at most one transition for each symbol and state. For our purposes, there will be one transition for each event and state. You use a deterministic finite state machine when you must have valid outputs for every possible valid input. It's also handy for identifying particular error conditions. Compilers can use a deterministic finite state machine. They have the advantage of a formal input grammar. There are tools to generate parse tables. Protocols also generally have a formal definition. We don't have a formal input grammar for group activities. We can draw state transition diagrams for some flows. We won't map out all the flows right off, but we can discover them along the way. This can get out of hand. It's important to limit the scope of a hand-built state machine. Don't try to make it control your entire app. For group activities, I suggest limiting it to the OSI session layer. By the way, the documentation at swift.org states that Swift uses recursive descent for its parser. A state transition diagram is a good way to describe the flow of events in a state machine. Each box represents a state. Each line represents an event which triggers a state transition. I drew this with Lucidchart. Hand-drawn diagrams usually have a circle for each state instead of a box. You can make do with a simple list of states and event pairs. Start out by listing all the events which may occur: eligible, ineligible, session start, session end, and so on. You'll need the again and next events for looping and for unconditional transitions. You'll probably miss some events. You add them later and either modify existing flows to incorporate them or add new flows. The startup state, also called init, executes the code to initialize or reinitialize the state machine. Idle is the state where the state machine waits for the first event. You will add states as you discover more flows. This is one less naive, happy path to establish a group activity session. It depends upon the connected gadget to determine which device in the call activates the activity. There are multiple possible happy paths. You can connect a gadget before or after starting the FaceTime call. There are also unhappy paths. Some of those unhappy paths are worth paths of their own, with prompts to tell the user how to fix it. It's your choice whether you diagram each flow separately or put all the flows together in one diagram. If you diagram multiple flows together, it can be easier to see where they split or join. The code to implement these flows tends to be hard to follow. This is the state table, which corresponds to the state transition diagram in the previous slide. We record the flows in a two-dimensional array of states, indexed by the current state and event. Each row has an entry for each possible event. The first column in each row always contains the state which corresponds to that row. That lets you identify the row by I. It also means that the again event is treated like any other. Put an array of events above the state table with the events in order. It will help you keep track of which column is which. This is the secret sauce. There are no flags. Never check the state. Never change the state anywhere else. Operations return events. All flows are in one place where you can see them, and you can trace them through, step by step. You will have talking heads moments. Fill the empty entries with a third state. Call it invalid state or something similar. That is the state which lets you know that you had an unexpected event. Leave a trail of breadcrumbs. That is, log each transition so that you know how you got there. It makes debugging much easier most of the time. Implementing a state machine this way has a number of advantages. In particular, it separates the flow from the operations and bookkeeping. All the flows are in one place. It is easy to follow, step by step, the sequence of events which trigger state transitions. You can still make mistakes, you will still have bugs, but you will explicitly deal with all the possible events in every state. This is the heart of the state machine code. The inputs are the current state and an initial, usually external, event. The loop repeats until one of the state functions returns the again event. Each state transition is logged. This is the trail of breadcrumbs, which tells us how we got to wherever we are. You can walk back through the sequence of events to find your mistake. The state machine executes in its own sequential queue. Calls to the execute states function add the closure containing the call to the state loop function to the queue. This is not the latest and newest and shiny, but that comes later after I get it all working. Here are a couple of state functions. Each is as simple as possible. Notice that they return hard-coded events. They do not test or alter the current state. These functions can be called for any state which performs that particular operation. The power of this technique is that the flows are completely separate from the operations, and the flows are all in one spot. Again, you never check flags. You never check the state. You never change the state from in one of the operation functions. Each state function returns an event. In most cases, that event will either be again or next. The other events come from outside the state machine. The end of the flow is called a terminal state. In the state before it, the function calls an external object to hook up the object graph that will handle application-level messages to and from the other end of the call. In my current version of the app, I've broken one of those. The state machine will not be involved again until another event, such as a disconnected gadget or a disconnected group activity session, starts another flow. There are limitations to this technique. If you get too ambitious, this table can grow far too large to deal with. Without machine assistance, it's best suited to things like implementing protocols, where all the possibilities must be covered. The state table explicitly covers all the bases. I concluded that I needed code dedicated to managing the session and which does nothing else. Once the session is established, the application can send messages back and forth. A state-driven deterministic finite state machine is a very powerful technique. I hope you will consider building one the next time you implement a protocol. Separate the state flows from the state operations. Consolidate state flows in one understandable place. Reuse state operation code everywhere applicable. Cover all the bases. And here comes the attempt at a live demo. Now let's see if it actually works. Let's see. Oh. And now let's see if I can share a picture of the screen. You can't record the screen during a FaceTime call, or at least maybe there's a. Let's see, where'd that go? That's what I'm trying to do. Well, that's that. Yeah. And two things in my hands at once. I'm a programmer, not a I'm trying to get a hold of the camera. There we go. And there's the camera. And here's the user interface. I don't know if you can see that. Oh, that's what's wrong. Hello. Well, you didn't get to see all my fumbling, which is a good thing. Yeah. There we go. And that's what the user interface looks like now. There are ways to get around the picture-in-picture size limitation. You can tell Apple that you are that you need background processing in order to deal with Bluetooth, and that will keep your app alive in the background so that you can make FaceTime full screen. And there are other things you can do, but that's... Now let me go back to my concluding slides. And yeah, if you want to try it, the address of that particular device is the top address there, test1.cocklebur@gmail.com. And that's the URL to my public beta. And so anybody who wants to try it, and that's the end of my talk. That's all I have prepared. So